Hey, this is Dr. Green. We're looking at WebAssign Homework 8 and problem number 17. So we have a researcher here who recorded the amount of time that a sample of 10 students engaged in active play. There were 5 students in the class that used group games. We're calling that group A. And then 5 students in the class who did not, and we're calling that group B. So here's the data for the 5 students in group A and the 5 students in group B. They ask us, use the normal approximation for the Mann-Whitney U test to analyze the data. Need a z-score and then hypothesis decision here. So here are the steps of the normal approximation. What you do is, well, first of all, your null hypothesis is that the ranks in the groups are equally dispersed, and your alternative is the ranks in the groups are not equally dispersed. So it's essentially saying the groups are the same, the groups are different. But it's looking at ranks instead of the actual data. So what you do is you combine the scores from both the samples and then you rank them in numerical order, but keep track of the scores that come from each group. And then you assign points, and each A sample is going to get 1 point for each B sample value that ranks below it. And vice versa. So what we're doing is we're trying to look at each value from each group and see how many values from the other group that it ranks above. So you sum the points in each of the groups to find your test statistic, which we denote that as U. And then your mean is the number in each of the 2 groups divided by 2. And then this is your standard deviation. We figure a z-score for that test statistic. And our rejection region's the same as it was for the rank sign test, which was problem 16. So let's take a look here. So first of all, what I did was I took the data here and I brought it down and I put it in ranked order here from smallest to highest. So the smallest scores we're going to rank as a first, rank 1. Second smallest score we're ranking 2, so smaller scores have higher ranks the way we're setting this up. But we want to keep track of which samples these numbers came from. So first of all, the A sample was the 15, 6, 11, 8, and 12. So the 15, the 6, the 8, the 11, and the 12. And then everything else was B samples. So we combined the 2 groups and then ordered them from lowest to highest, giving the lowest numbers higher rank. And then we assign points this way. So we look at this this 4, which is a B score, and it's ranked above 1, 2, 3, 4, 5 A scores, so it gets 5 points. Go down to the next B, it's ranked above 1, 2, 3, 4 A scores, so it gets 4 points. Go down to the next B, it's only ranked above 1 A score, so it gets 1 point. And these 2 Bs, they're not ranked above anything in terms of A's, so they get 0 points each. This A, now we look for B's that it's ranked above. It's ranked above 1, 2, 3, 4, so it gets 4 points. This A is ranked above 1, 2, 3 B's. This A is also ranked above 3, and this one too. And then this A down here is ranked above 2 of them. So now we sum up the ranks for A scores and the ranks for B scores. So for A scores, we've got 4, 3, 3, 3, and 2. So 4 plus 3 plus 3 plus 3 and plus 2, which is a total of 12. And then the B scores, 5, 4, 1, 0, 0. And we add those up. And that gives us a total of 9. And then the value of our test statistic is the smaller of these 2. I'm sorry, that's a total of 10. 5 and 4 is 9, plus 1 is 10. The U statistic is the smaller of those two, which is 10. Okay, so that's our test statistic. So now we bring that down here. We got to compute our mean, standard deviation, and then the z-score of our test statistic. So the number in the A and B groups were the same. They were both 5. So this is going to be 5 times 5 divided by 2. So that's 25 halves, 12.5. So here, let's scooch our standard deviation over, give ourselves a little more room. So this was 5 times 5 divided by 2, 25 halves, 12.5. This is going to be the square root of, this will be 5 times 5. And then this is 5 plus 1, so 10 plus 1, 11. 5 times 11, divide by 12. And if we pop that in the calculator, we get 4.787. Now we can figure the z-score of our test statistic. So the U was 10. And then the mean that we computed up here was 12.5. So 10 minus 12.5. And then divide by our standard deviation here, the 4.787. And if you compute that in your calculator, you get negative 0.52. And then that negative 0.52 is between the two cutoffs for the rejection region. It's not extreme. It's not past 1.96. It's not past negative 1.96. So we're going to retain H0. So our Z is negative 0.52. And we are going to retain the null hypothesis. And that wraps up that question.